Hey, this is 2.6, Investing in Yourself, Education and Home Loans. All right, prep skill questions. Again, if you want to try these on your own, you can pause the video and then unpause when you're ready. All right, so number one, they want us to evaluate this uh, formula given these conditions. P is 500, R is 0.0475, N is 6, T is 5. Okay, so this is just plug and chug. So here we go. So we're just going to enter this in. 0.0475 divided by n, which is 6, and then raised to the 6 times 5 power. Okay, so this is probably going to be an approximation. All right, so we're just going to enter this in one swoop. All right, so 500, open parentheses, 1 plus 0.0475 divided by 6, close your parentheses. Now raise it. Now again, if you have an 83, this is where you want to open your parentheses and then just type in 6 times 5, or you can just type in the 30. You can do 6 times 5 in your head and just type in 30 and then close it out. So this is going to give approximately 633.44. Now, there was no unit given, so I'm not going to put a unit for my answer, okay? Other than make sure that you use the approximation symbol, okay? All right, it says compute simple interest on a $12,000 loan at 9% for 3 years. Simple interest. So that's I equals principal times rate times time. So 12,000 principal times rate, that's going to be 0.09 times time, which is 3 years. Okay, so 12,000. Sorry, let me do this. And I have junk all over my desk here. 12,000 times 0.09 times 3. So that gives us $3,240. Okay. Now, number 3, compute the future value of a $3,700 deposit that draws 4.95% simple interest for 18 months. We're finding the future value using simple interest. So that means we're going to use this formula. A equals P times 1 plus R times T. All right. So A equals P times 1 plus R times T. So 3,700 times 1 plus 0.0495 times 18 months. T is supposed to be in terms of years, but they've given us 18 months. Okay, well, that's an easy fix. Anytime they give you months, you're just going to divide it by 12. Okay. Now, I made this comment before. You have to be careful whenever you are doing this division stuff because a lot of you want to immediately turn any fraction into a decimal and you don't care what it is. But you have to be careful because sometimes you get an exact decimal, which means the decimal stops on its own. And then sometimes you get something like 0.333333 that goes on and on. And then once you stop that number, it's no longer exact. We need exact values. We don't round until the very end. Okay. Now, 18 divided by 12, that's 1.5. So you would be very lucky if you entered in 1.5. However, if I did, let's just say that for some reason it was for 17 months. And so you did 17 divided by 12 and you said, oh, I'm going to use 1.41 or 1.4 or 1.42. Well, you just kicked this number out of being exact. Okay. So what am I saying? Just keep the fraction because you're going to number crunch. So who cares, what this is really going to become. All right. And besides, well, anyways, so I would just keep the fraction. All right. So we've got 3,700 open parentheses, 1 plus 0.0495 open parentheses. I'm just going to punch in 18 divided by 12. So I close that parentheses. Then I have to use another parentheses to close the whole thing. Actually, I don't. Um, but, and I'll show you. 3,700 times 1 plus 0.0495 times 18 divided by 12. I could leave it like this and not worry about having to close it and still get the answer. Okay. I believe if you have an 83 and you try to do this, it's going to tell you you have to close it. You have to close those parentheses. Okay. But you technically don't have to on the 84s, I think. And I think the 84 and a regular 84, it works the same way. Okay. Anyways, so we get $3,974, approximately $3,974.73. All right. So compute the future value. Yep. That's how much this will be worth at the end of 18 months. All right. So learning objectives, compute interest and monthly payments, analyze various aspects of mortgage, compare mortgages of different length. All right. The Petty family plans to buy a home for $244,900 and has been offered a 30-year mortgage with a rate of 5.5%. If make a 20% down payment. All right, calculate the down payment and the amount they will have to borrow. Okay, so we've done this. This is what we did in section 2.5. All right, so the down payment is going to be 20% of the $244,900. Okay. All right. So what is it? So 0.20 times 244,900. And that's $48,980. All right, so that's the down payment. So now the amount financed is the amount they will have to borrow. Okay, so we're going to take the 244,900 and we're going to subtract the 48,980 from it. So 244,900 minus 48,980. And so they are going to finance. Whoa, hang on. What happened? 48,9. Oh. Um, oh, you know what? Let me see something real quick. Oh, okay. Sorry, guys. So I was looking at, again, I had said this in an earlier video that these videos, this video is after I've covered this material in class. So I just realized I have my notes from lecture and this amount I had for some reason, I don't know why I changed this amount to 224,900, but anyways, it's still the same process, so it's no big deal. All right, so I'm just going to keep the 244,900, but I think in your notes, you probably have 224,900. So your values are going to be off just a little, but the process is still the same. So they are going to finance $195,920. Okay. All right. Now, this amount financed is going to be your PV. That's the present value of the loan. 195,920. How much will they have to pay for the life of the loan? Okay, well, it's a 30-year mortgage. You make monthly payments, so that means it's going to be compounded monthly for 30 years. We have an interest rate of 5.5%. We have to find our payment. How much are we going to be making? How much will our monthly payments be? Okay. We want the future value to be 0. And then because this is compounded monthly, our PY and CY will be 12. Now remember, this is the section that I had mentioned earlier where our PY and CY we're going to be changing. Okay, so I need to find our PMT. So apps, get to the TVM solver. So I'm just going to enter in 12 times 30 because I'm lazy. And then 5.5 for our percentage rate, 195,920 for our present value. We want our future value to be 0. Then it's 1212 end, and we're good. So we go back up to PMT, alpha, enter. So our payment is going to be $1,112.41. All right. Now, that's our monthly payment. Now, how much will they pay over the life of the loan? All right. So that means that every month for 30 years, that's going to be 360 payments of $1,112.41. All right. So this is the total installment. All right. So that's going to be 360. All right. Oh, plus the down payment of the 48,980. Okay. So here we go. So 360, oops, sorry, second quit. So 360 times 112.41 plus the down payment. I have to add that back in. That's not right. Oh, wait a minute. I'm sorry. Hang on. We don't need to add this back. So sorry. Life of the loan. Okay. So 360 times. Oh, that's why. Okay, now this will be better. There we go. 400,000, 467 and 60 cents. Okay, that's the life of the loan. Okay, that was it. Okay, now let's look at an amortization schedule. So find the interest. So step 1, we find the interest for the first month. We're going to use I equals PRT. Okay, where T is 1/12 because we're looking for the interest on the first month. So for 1 month, it would be 1 out of 12. Okay, so we enter that value in the column labeled interest. We subtract the interest from the monthly payment to get the amount paid on the principal. Now we're going to enter that amount on payment in the column labeled payment on principal. Subtract the amount of the payment from the principal found in step 2 from the principal to get a balance of the loan, and we enter that in the column labeled balance of the loan. Then repeat the procedure until we are done. Okay, so it's easier to just show you. So here's what we're going to do. All right. So fill in the table. To fill in the table, we will use the steps to compute the first 3 months of an amortization table for the Petty's loan. The principal is 100. So I don't know why they changed the numbers here, but this is from the book. So the principal is $179,920 at 5%, 5.5%, with a monthly payment of $1,021.57. All right. We're going to calculate the interest on the first month. So we're going to use I equals PRT like they told us. Okay. So interest is going to be the principal, which is 179,920 times the rate, interest rate, which is 0.055 times the time. And we were told to use 1/12 because that would be representative of the first month. Okay. And we're going to number crunch this out. So 179,920 times 179,920 times 0.055 times, and again here, if you type in 1 divided by 12 to get a decimal, you're going to get an ugly number. So just leave it as a fraction, 1 divided by 12. Okay, now we round. So we're going to be, our interest for the first month is going to be approximately $824.63. Okay, so now when we start, so payment number 0, that's just the balance of the loan, which is your principal. So that's the 179,920. Okay, so we had just calculated for the first payment, the interest is going to be $824.63. All right. Then we were told, now we subtract the interest from the monthly payment to get the amount paid on the principal. So our monthly payment is $1,021.57. I'm going to subtract the interest that we just found, the $824.63. So that means this is going towards the principal, the $196.94. 196.94. All right, so if I add these two together, I'm going to get the $1,021.57. So out of that, $824.63 is going towards the interest, and $196.94 is going towards the principal. Now, what's the balance of the loan? Oh, I didn't write that step here. I'm so sorry, guys. So that's $1,021.57 minus the $824.63, and we get $196.94. Okay. All right, now we calculate the new balance of the loan by subtracting the payment on the principal from the original principal. So the payment on the principal was the $196.94 from the original principal, which is the balance of the loan. So we're going to start with this 179,920. We're going to subtract the 196.94. Minus 196.94. So we get 179,723 and 6 cents. Okay, so that's the balance of the loan. All right, now we do this all over. Same steps. Okay, so now I'm going to take, this is my new balance. So for the interest, this is going to be 179,723.06 times 0.055 times 1/12. Again, because now we're finding the next month. All right. So this is month number 1, month number 2, and month number 3. Okay. So here we go. So 179, no, 179,723.06 times 0.055 times 1 divided by 12. And we get $823.73. $823.73. Okay. So this is 823.73. Okay. Now we're going to take this amount, we're going to subtract it from our monthly payment of $1021.57. Okay. 1021.57 minus 823.73. So that's 197.84. All right. 197.84. Then the balance of the loan. I forgot to write this up here from the first month. Okay. Now the balance on the loan, so that's 179,723.06 minus the 197.84. So lots of calculating. And you need to be very careful when you're doing all this back and forth because it's very easy to lose your place. Okay, 179, 525 and 22 cents. 179, 525 and 22 cents. Okay, last one. So interest, now we've got a new principal or a new balance of the loan. So that's 179, 525 and 22 cents times 0.055 times 1/12. Okay. So we're going to number crunch that. Let's get this over. Okay. So here we go. 179,525.22 times 0.055 times 1 divided by 12. 822 and 82 cents. 822 and 82 cents. Okay. Now we subtract that from our monthly payment. And 21.57 minus 822.82. So that's 198.75. Okay, that's what we write here. 198.75. And then the balance 179,525.22 minus 198.75. That's going to give us a new balance. 98.75. 179, 326, and 47 cents. 179, 326, and 47 cents. Man, that was kind of a pain. Or not kind of, that was a pain, right? Okay, so that's how an amortization schedule works. Now, normally, uh, well, this is something that the mortgage company would handle for you, and they give you a book, or I guess they still give you a book. I don't know, but you mail in your payment the uh, with a coupon for every month that you make your payment. Okay, and then it just gradually will come down. Now, notice if I were to add these two together, these two columns together, well, sorry, if I were to add these entries for each row for these two columns, I would always get back my monthly payment. So what this is saying is that the reason why uh, we do this is because most of the payment, when we're talking about a house payment, most of your payment will go towards the interest because that's what's eating up uh, your loan is the interest. So if you can get that interest down, then the rest you'll be gradually, if you notice, little just within the first 3 months, you can see how it's so tiny. It's not even $2. Okay. But, little by little, the interest amount is gonna start working its way down. And again, look at what happens for the principal. So if the interest is decreasing, then that means that the rest is going to be going towards the payment on your principal. Okay, and that's what we want. So, they always talk about even if you can make um, an extra, if you can double up on a payment, or if you can pay more than what is required on your house note, the more you can pay on that house note on your payment per month, then the quicker the interest is going to go down, and then the life of that loan, is going to begin to shrink, and then you might not have to pay it out over the 30 years or however long, you took out the loan for. Okay. All right. So let's look at example 4. So it says once an antibiotic is introduced to bacteria, the number of bacteria decreases exponentially. For example, beginning with 1 million bacteria, the amount present T days from the time streptomycin is introduced and is given by this function. Looks yucky. Round to the nearest thousand, determine how many bacteria are present after 6 days, 1 week, and 2 weeks. Now, the function that they give us is our variable is the T, and T represents the number of days. Okay, so for A, I'm good. I know that here, this means that T is going to be 6. But for B and C, I'm given weeks. But we know how many days are in a week. So there are 7 days in a week, and then there are 14 days in 2 weeks. Okay, so now I know what I can plug in. And that's all I'm going to do, guys, is we're going to take this number and we're going to plug it into our function. So the way we do this is we find A of 6. Now, this is important that you show this step. Don't just plug a 6 in right here and give me a number. You show me A of 6. That tells me that you're plugging in 6 days into this function. So this is going to be 1 million times 2 raised to the minus 6 divided by 10 power. Okay. And then we're going to do the same thing for A of 7. So that's 1 million times 2 to the minus 7 divided by 10 power. And then A of 14. Again, 1 million times 2 raised to the minus 14 divided by 10 power. Okay. Now, all of these, we're going to get approximations because they've already told us that we need to round to the nearest thousand. Okay. But all this is number crunching. And your calculator is going to do all the work. So 1 million times 2 raised, and you have to be very careful here. Please make sure that you are raising this exponent is going to be a negative and it's a fraction. So you got to be really careful when you enter this in, especially those of you that are using the TI-83s. Remember what I said, open your parentheses and type all this stuff in. So the first one would be raised to the minus 6 divided by 10 power. And we have to round this to the nearest thousand. So the 9 is in the thousands place. So I look at the 7. The 7 tells me to bump the 9 up, which means I have to bump the 5 up. So this is going to be approximately 660,000 bacteria that will be present after 6 days. So it's doing its job. It's killing the bacteria. Okay. Now I need to evaluate at 7 days. Well, I'm just going to back up, grab that function, scroll over, replace the 6 with a 7, and now round to the nearest thousand. So we're going to get 616 approximately. Uh, Hang on a second. Yeah, 616,000 bacteria. Okay. So just a day later, notice that it's not killing off as many. Okay. And then to the 14th, so I'm going to back up, grab the function. So 14 divided by 10, I have to override that, but just make sure that it's still in your exponent. And this would be approximately 379,000 bacteria. So after 2 weeks, I three, well, it's less or dying off. Okay. So I'm not sure how this medicine would work, but uh, I'm and how often it's given, but they would want to make sure that the bacteria wouldn't start, coming back, growing back. Okay. So I'm sure they would look at that very closely. Okay. All right. So let's look at example 5. So now we're getting back to the TVM solver and we need to be careful in this section. All right. So let's read through these problems. All right. Miguel wants to buy $3,500 worth of furniture from a store that's offering 3-year financing with no money down and 11.99 annual interest. Find his monthly payment, total installment price, and the finance charge. Okay. Well, first, I have to find the monthly payment before I can find any of this other stuff. Okay. So no money down. Okay, good. So that means my PV is going to be 3,500. My interest rate is 11.99. We're looking for monthly payment, so compounded monthly for 3 years, so 12 times 3. I want the future value to be 0 since we're compounded monthly. Both of those are going to be 12. And then it's going to be for these are always going to have end for this last block. Okay, so here we go. So go to the TVM solver and let's crunch this in. 12 times 3, 11.99, 3,500. We're looking for payment and then future value 0, PYCY 12, and we're good. So payment, so we go alpha solve. So our monthly payment is going to be $116.23. All right, so monthly payment is $116.23. All right, the total installment price, so that means that 36 times we're going to be making these payments. So 36 times, let's get out of here. 36 times 116.23. So that's 4184.28. 4184.28. Okay. Now the finance charge. Remember, this is a way of finding the interest. So at the end of the loan, it's going to cost Miguel $4,184.28 that he's going to end up paying on furniture that cost him $3,500. So we subtract those two amounts. Okay. So the 4184.28 minus the 3,500, that's $684.28 in interest charges. Okay, that's the finance charge. Okay. Now, example 6. How much would you earn if you deposit $2,300 in an account earning 1.98% compounded continuously for 4 years? Okay. And then what is the percentage amount of the interest earned? All right. Compounded continuously. So that means I am using that formula. Okay. So this is not a TVM solver question. So our P is going to be 2,300 times E raised to the 0.0198 times 4 power. Okay, so we're going to get a future value here. So 2,300. Now remember, your E button is going to be second, and then press the LN button to get the E. Now we're up in our exponent. So again, 83 users. Make sure you put all this in parentheses. 0.0198 times 4 power. And so our future value is going to be 24.89 and 57 cents. So $2,489.57. Okay. Now, the next part says, what is the percentage amount of the interest earned? Okay, well, the interest earned, so this part, Okay. How much would you earn? Okay, so this is the first question. That's that part. Okay, we answered that. How much would you earn? We would earn that much. Now we're going to find the percentage of the amount of interest earned. Well, I first need to know how much interest that I earned. So that's just like your finance charge. So we take our interest is going to be the 2489.57 minus the 2300. Okay, so 2489.57 minus 2300. So that's 189.57. Okay, now I'm going to take this amount to find the percentage of interest earned. I take this amount and I divide it by how much I ended up getting. Okay. All right. So let's do that. Hang on a second, guys. I think oh, it didn't. Hang on just a second. Okay. So, so we're going to take the 189.57, and we're going to divide it by the amount, our future value was the 2489.57. So this is the percent of interest earned. All right. And we just number crunch. So 189.57 divided by 2489.57. So we're going to round this to 2 decimal places. So if you multiply by 100, okay, now it's a percentage because I multiplied that decimal by 100. Now round this answer to 1 decimal. We'll just take 1 decimal. So this is going to be approximately 7.6%, right? That's the amount, that's your percentage of the interest earned. Okay. All right, now let's look at the next one. Jamal is thinking about buying a MacBook for $1,700. They can get financing from Apple for 6 years at 13% annual interest. Find his monthly payments. Sorry. Find his monthly payments, the total amount paid on the loan, and the finance charge over the duration of the loan. Okay, so let's start filling in what we've got. So his present value is going to be $1,700. The percentage rate is 13. The interest is 13%. So that's 13. Let's see. We want the future value to be 0. Since we're having to find monthly payments, that means this is going to be compounded monthly for how many years? And it told us 6 years. So that means that PY and CY are going to be 12. And we're looking for PMT first. Okay. So we're going to enter this in. So 12 times 6, then 13, 1,700, then the rest is okay. So we're looking for payment. So alpha solve. So he's going to be paying $34.13. Okay. So monthly payment. So this is just like example 5. Monthly payment is going to be $34.13. So the total amount paid on the loan. So he's going to be making 72 payments of $34.13. It's a second quit. So 72 payments of $34.13. So that's $2,457.36. And the finance charge, so we take the $2,457.36 and subtract the original amount of the $1,700 from it. So $757.36. That's how much interest Apple is charging him over the 6 years. Okay. All right. Let's look at example 8. It says you deposit $1,000 in an account that earns 6.5% interest compounded daily for 20 years. How much will the investment be worth at the end of 20 years? Find the percentage amount of interest earned and the percentage towards the principal. Okay. All right. So we have to be careful with this one because this one's going to be different. Now, we have this compounded daily. So remember, that's going to impact what big N is going to become. Okay. So remember, big N, let me write this off to the side. Remember that big N is made up of little n times t. So that's your compounding period. And t is the number of years. So this is compounded daily. So that means little n is 365. And the number of years is going to be 20. Okay. Our interest is going to be 6.5. Our PV is going to be $1,000. That's what we deposit. We're putting that in. Okay. So that means that's going to be negative because you're putting that amount. It's coming from somewhere. Okay. All right. Now we're not making any payments. So that's 0. It says, how much will the investment be worth at the end of 20 years? So that means I'm looking for FV, your future value. Now, since your compounding period is 365, it's compounded daily, then here is where we change the PYCY. Okay. All right. So that's where this is going to change. All right. So 365 times 20. Our interest rate is 6.5. Our PV is negative 1,000 because we're putting that into the bank or whatever institution. Our payment, we're not making any payments. We're solving for FV, so I have to scroll past it because I have to change the PY to 365. But when you automatically change PY, CY changes as well. Okay, so we're going to go back to the future value and do alpha, enter. And so you should end up with $3,668.87. $3,668.87. Okay, so that's how much our investment will be worth at the end of the 20 years. Now, it says find the percentage amount of interest earned and we don't need to worry about the percentage towards the principal because this isn't uh it's not that type of problem. So the percentage of the interest earned, well, I need to know how much interest I did earn, so that's future value. Now, I can't subtract, it doesn't, well, yep. So we deposited $1,000 at the beginning. So the interest earned is going to be the 3668.87 minus the $1,000 that we deposited. So it earned us 2668 and 87 cents in interest. Now, remember, we've done this already. So we take, so to find the amount, the percentage of interest earned, you take how much interest that was earned and we divide it by that future value. So the percentage of interest earned is going to be the 2668 and 87 cents divided by the 3668 and 87 cents. Okay. Oops. 87. Oh, what am I doing? Sorry. So 2668 and 87 cents divided by 3668 and 87 cents. Okay, I'm going to multiply that by 100. So there's my percentage. So let's round this to one decimal, so 72.7%. Okay, and that's the second part of the question. Okay, good. All right, example 9. If you wish to accumulate $140,000 in 13 years, how much must you deposit today in an account that pays an annual interest rate of 14%? How much would you deposit over the life of the investment? All right. So we are going to do what? So we want to accumulate $140,000. So that's not present value. That's what the future value would be. So we want $140,000 at the end of this period. Okay. I know the interest rate is 14%. We are not looking for a payment and we're not making monthly payments. Okay. So it said, how much must you deposit today? So that would be the PV. So this is what I'm looking for. Okay. Now, it says that the account pays an annual interest rate of 14% annual. So that means this is compounded annually. So once a year for 13 years. Okay. So since that is 1, then the PY and the CY are going to be 1 because it's annually. All right. So here we go. Wrong button. There we go. Okay, so 13 pays 14%. We're looking for PV. Payment is 0. We want the future value to be $140,000. Our PY and phi are going to be 1. So we're going to go back to PV, alpha, enter, and there's our answer. Now it's negative because it said how much would we have to deposit today? All right. So that means that we would have to deposit $25,489.71 so that we could get $140,000 back out in 14 years. Okay. I don't know why there's two questions. It's the same, and it's the same question. So I really don't know what happened here with the notes. Something weird went on. Okay, so let's run through these last three really quick. At what annual interest rate must $137,000 be invested so that it will grow to $475,000 in 14 years? Okay, so we're looking for an annual interest rate. All right. So that means our compounding period is 1. And for 14 years, we're looking for the rate. Now it said, what would the rate, at what rate must this amount, the $137,000, be invested? So if we're investing the $137,000, that's going to go in as a negative number. So that's $137,000 so that we can get back $475,000. So our FV is that amount. And then payment is going to be 0. Now, our compounding period is 1, which means the PY and the CY are both going to be 1. Okay. So we're just going to change this. This becomes 14. And then we're looking for the interest rate. This is going to be negative $137,000. Payment is 0. And our FV, future value, is 475,000. PYCY is 1. So we go back to our interest rate and do alpha solve. And so that means this is going to be approximately 9.29. Okay, so the interest rate would be approximately 9.29%. Okay, that's it. That's all we had to do. Okay. Kennedy wants to purchase a car that costs $24,690. What will her payments be if she pays off the car in 12 years with an annual interest rate of 5.4%? What will be the total amount paid on the loan? How much of that is interest? Okay, so hopefully by now you know what we're going to do. So there's no down payment. So the car costs $24,690. So that's the present value. We are looking, we're going to have to find our payment. How much is she going to pay per month? That was not given to us. So the interest, the annual interest is 5.4%. She wants to pay the car off in 12 years. So that means that every month for 12 years, so the compounding period is 12, which means our PY and our CY is going to be 12. And then we want the future value to be 0. Okay, so we have all our values. So here we go. So 12 times 12. Then we have 5.4 for the I%. Our PV is 24,690. We want the future value to be 0. Since this is compounded monthly, PYCY is 12. We're looking for payment. So scroll back up to payment, hit alpha enter. And so her monthly payments are going to be $233.34. Okay. Now, that's not anything of what the question's asking, but we had to find that so that we can answer the question, what will be the total amount paid on the loan? All right, so the total amount. So she's going to be making 144 payments at $233.34. Okay, so 144 times 233.34. We get $33,600. $33,600.96. Okay. And then how much of that is interest? Well, we should know how to find the interest. So the interest is going to be this 33,096 cents minus the cost of the car, which is 24,690. So 33, where did my number go? I'm covering it up, but I have a cheat sheet. 33,600.96 minus the 24,690. So $8,910.96 is how much interest she's going to pay. All right, last question, then we're done. How long will it take for an investment to triple in a monthly compounded account with an annual interest rate of 5.3%? Okay, so how long means I'm looking for big N or something over here with that. I have an annual interest rate of 5.3%. Okay. Now, what else do I know? Well, it says that my compounding period is monthly. Okay. Now that helps me out for the PY and the CY, but I can't plug that in here. I can't do anything with the compounding period because remember, big N is made up of your compounding period times the length of the number of years. So I don't have that, and I can't put 12 in here because I don't know what the number of years is. And that's part of what I have to figure out. Okay. Now, all right. So now I know that there's no payment involved. So now I'm stuck with this PV and the FV, my present value and future value. Okay. Well, look, it doesn't matter what we put in. We just want whatever we put in. We want to know how long is it going to take for it to triple. Okay. Well, let's put in $1 because the dollar value isn't going to matter, and I'm going to prove it at the end. So if I invest $1 and I want my dollar to triple, then that means I want $3 back. If I were to put in $6 and I want my $6 to triple, I would want $18 back. Okay, so I'm just going to leave it like this. Now I can solve for big N. Okay, so apps, get to our TVM solver. So our percentage rate is our interest rate is 5.3%. Our present value, we're putting in $1. We're not making any payments. We want the future value of that dollar to be 3 because we want it to triple. And then our PYCY is 12. Okay, so now I'm going to go back to N and hit alpha, enter. So we get 249.29. Okay, now that's just big N. That's the number of times the interest is going to be compounded. Okay, well, if this is compounded monthly, so remember, big N is made up of little n times t. So that's going to be 249.29 equals 12 times t. And t is going to be the number of years. And that's what I need. That's what I need to know is the number of years. So all we're going to do is take this amount, the 249.29, and divide it by 12. We're going to get a not so nice answer, but that's okay. So T is approximately 20.77 years. Or we can say that T is approximately 21 years that it will take for our investment to triple. Now watch. I said I would prove it. So let's say I'm gonna change these values, okay? So watch. So if we say that big N is gonna be 21, all right? And let's invest $5,000. And if I to triple, then that means I'm going to get back out 5 times 3. We're going to get back out $15,000. Okay. So now let's see if this is true. All right. So I'm going to go to apps. Now I have to make somebody an unknown. Okay. So let's see what the future value is going to be. We'll look for the future value. So big N is 21. We have 5.3. Our present value, we're going to invest $5,000. I'm going to clear this out. Well, this is where I'm going to do the alpha solve. So alpha solve. Uh-oh, wait. What happened? No, I did this the other day. I did this in class and it worked. I don't know what happened. Um, I don't think this is it. Huh. No, something's not right. I did this in class and it worked. The future value, this should be a tripled amount, and it's not. So what happened? Um, let's see. Hmm, I don't know. But anyways, I showed you how to do it. So if you do it that way, you'll get the right answer. But I don't know why this isn't working because we did this in class and it did work. So again, I don't know what's going on here. But okay, so that's it for all of the material for chapter 2. So if you have any questions, let me know and I'll try to figure out what went wrong here. But anyways, so that's it. Let me know if you have any questions.